Welcome to my birthday train ride. We just arrived and looking forward to getting on the train to take our scenic tour. Sit back and relax and enjoy the ride. Right here at the motor. Noisiest seat in the house. They're leaving us behind.
We've come to a stop so our train crew can do what's called run around the train. Now this doesn't mean you'll see any of our train crew physically get out and run around the train. Run around the train is a railroad phrase for the process of decoupling the locomotive from one end of the train and recoupling it to the other end. Procedures for a runaround move are simple and safe. It begins by stopping the train. The conductor manually tightens the brakes. You may hear a ratcheting noise when he is doing this. That is the chain being drawn tight, applying the brake shoes to the wheel. After the shoes are tightened, the locomotive can bump slightly against the train car to make sure the brake shoes are holding the train car in place. Last thing we want is a runaway coach car. After the brakes are verified as applied, the conductor will cut the air supply off to the passenger car from the engine and separate the two pieces of equipment. The conductor communicates with the engineer that he is in a safe spot, that he has opened the knuckles, and that the locomotive can now separate away from the passenger car. Trains do not rely on brake fluid. Instead, all braking is applied through movement of air throughout the train. Each locomotive is equipped with its own air compressor. This compressor generates the air that is then moved from the air tanks on the locomotive through a pipe to a black hose which you see at the ends of each and every locomotive and/or freight and passenger car. They are called air lines. These air lines are connected manually by our conductor, and they are held together by a device known as a glad hand. Think of a handshake. Each end of an air line has a glad hand that can lock together with another glad hand. Each and every car is coupled together not only with what is called a knuckle, but also by air lines. When our locomotive engineer applies the brakes, he can release pressure through the air lines to not only apply braking to the locomotive, but also braking to the rest of the train in the consist. Now, back to the runaround procedure. As the engine separates from the train, the switch for the siding up ahead is controlled remotely from the Buckingham branch dispatch office in Stanton. Signal systems, much like a stoplight on the highways, are used to communicate with trains. When the light is green, a train can go past. When a light is yellow, a train must slow and prepare to stop. And when a signal light is red, it must stop, not going past the red light. These colored lights are operated from our dispatch office. Communication of where the train is on the track is also done through the rail. The rail acts as a conduit to transfer a signal back to the computer software, indicating to our dispatch team where the train is. Dispatch teams communicate with each train engineer, letting the engineer know what's up ahead. Here, our engineer will communicate with dispatch via radio walkie-talkie to verify the train can proceed out of one track and come down another to run around the train. Once the locomotive clears the switch point, the engineer can change direction of the locomotive simply by moving a lever, going from moving forwards to going backwards. The engineer can see out both ends of the engine. Locomotives can run safely forwards or backwards. As the engine passes, be sure to wave to our train crew and see if you can get them to sound a horn. As the engine heads back to the other end of the track, there again our dispatch team will remotely throw the switch for the locomotive, aligning the switch so the engine can come onto this track. As the locomotive approaches, the engineer will slow down the speed in preparation for coupling to the other end of the passenger car. As the engine approaches, the engineer is watching carefully to see how close they get in order not to bump the car too hard when recoupling to the passenger car. As the engine couples, you may feel a slight bump of the car. This results when the knuckle on both the passenger car and the locomotive lock up. A locking pin drops between both knuckles, preventing them from opening. When our engine is coupled to the passenger car, the conductor will ask the engineer to give a little tug on the passenger car and see if they separate. This is done as a check of the locking pin. Finally, the conductor secures the air line from the engine to the passenger car. Once the air hoses are attached, the handbrakes can be released from the passenger car, and we are ready to head back out for the return portion of our trip.
Our nice dinner along with dessert. Complimentary glasses to go along.
To build these powerful machines. Today's diesel engines can generate upwards of 4,000 to 6,000 horsepower and 137,000 foot-pounds of traction effort. Traction effort is defined as the amount of linear output force, or how hard it pulls to get up and going. More modern diesel locomotives also weigh in excess of 390,000 pounds. Locomotives on the Buckingham branch and Virginia Scenic Railway often had previous lives dating back to the 1950s up through the 1980s. These locomotives began their careers operating for other railroads before our railroad acquired them. It's often much cheaper to purchase an older locomotive and fix it up as compared to buying new. New locomotives today cost in the millions of dollars to purchase just one. Over the years, spanning from Dawswell, Virginia to the Shenandoah Valley. A few years after the Civil War ended, the Virginia Central Railroad and the Covington and Ohio Railroad merged to form the Chesapeake and Ohio Railroad around 1868 to 1869. This allowed for a rail corridor to span from Richmond all the way to the Ohio River Valley by 1873. By the 1880s, the Chesapeake and Ohio expanded its eastern presence via the Peninsula Subdivision to Newport News, Virginia. For over 100 years, the Chesapeake and Ohio Railroad operated numerous networks of rail corridors. In the 1980s, the Chesapeake and Ohio was reorganized through a series of mergers and became what exists today as CSX Transportation. CSX had been the primary railroad operator of the line you're on today until Buckingham Branch Railroad founder Bob Bryant offered to maintain and operate the rail line on behalf of CSX. In 2004, the Buckingham Branch began its lease agreement for 212 miles of this line, stretching from AM Junction, just north of Richmond, through Dawswell all the way to Clifton Forge, Virginia. Most recently, December 2019, then Virginia Governor Ralph Northam announced a $3.7 billion transportation investment to include acquisition of more than 350 miles of railroad right-of-way and 225 miles of tracks, preserving an existing freight corridor of 199 miles between Dawswell and Clifton Forge for future east-west passenger service. Today, Amtrak, CSX Transportation, and the Buckingham Branch Railroad operate trains on what was originally the Louisa Railroad, later becoming the Virginia Central Railroad, and so forth, preserving this historical infrastructure for current-day freight and passenger rail service needs.
Thanks for joining us. Be sure to like and share. Go take your ride.